I already told you that rectifier is two types, half wave rectifier, full wave rectifier, right? Last class, I already explained you half wave rectifier. And this class, I already explained you full wave rectifier, bridge rectifier part, right? Now, the one topic is remaining, that is the center tap rectifier. Okay? So now let's go to the center tap rectifier. So now we will explain you about the center tap rectifier. Okay? For the center tap rectifier, it's little bit different than the bridge rectifier. In the bridge rectifier, we used a normal transformer. Okay? For the normal transformer, here we have a primary coil. Here we have a secondary coil. Okay? If this is a 230 volt primary coil, then suppose this is a 1:1 transformer. Then we will get this is plus 230 and 0. Okay? And this will switch, like this will plus, this is minus, and sometimes this is plus, this is minus. Okay? So this is just the normal case, what I explain you in this particular rectifier circuit. Okay? But for the center tap rectifier, we have a extra port in this one, and that is connected in the center of this particular coil. That's why it's called a center tap. Okay, so center tap, if this side is 230 volt, this will be plus 115 and this will be minus 115. Okay, and this will be 0. Okay, so what will happen for the positive half cycle? This will be plus 115 and 0, and this will be 115 and 0. Okay, and for the negative half cycle, what will happen? This just reversed. This will be plus 115 0, and this will be minus 115. So this one for the negative half cycle, and this one is for the positive half cycle. Okay, now based on this concept, I will explain you the principle of the center tap rectifier. So first, we will consider the positive half cycle, that means this waveform. Okay, for the positive half cycle, what we will get? We will get this is plus and this is minus, okay, and this is 0, right? That means I assume that this is D1 diode, this is D2 diode. Okay, so this one is the P, this is N, this is P, this is N. That means the P side of the D1 diode is connected with a positive terminal. Okay, so we can say that D1 diode is in the forward bias. Okay, similarly, you can see here for the D2 diode, P side is connected with the negative terminal with the input source, right? That means D2 diode will be in the reverse bias. Okay, that means the current will flow from the positive through D1 through load resistance RL, and then it will go back to the this one. Okay, no issue. So we will get the output voltage will be just follow the input voltage style. Okay, but if this is V, then we will get here V. Okay, here I call Vi. This Vi will be the input in this particular point and this particular point. Okay, this particular point input I called this Vi. Okay, I didn't take this input, I will take this input. That's why you can see Vi, and this will also the V, the same. Okay, you will not half. Understood? Now go for the negative half cycle. What will happen? For the negative half cycle, this will be negative, this will be positive, right? Then for the D1 diode, P side is connected with the negative part, and for the D2 diode, P side is connected with the positive part. That means D2 diode will be in the forward bias and D1 diode will be in the reverse bias. Okay, so this will be open circuit and current will flow from this side to this side and this side through the load resistance RL and then come back to the 0 point. Okay, generally this point is grounded. Okay, so you can see here for the positive half cycle the current is flow through the A point to B point, and for the negative half cycle also current is flow through the A point to B point, right? That means just like positive half cycle we will get the output same as the positive half cycle output. Okay, so it will not follow the input voltage, it will just opposite with the input voltage of the negative half cycle. Okay, so for this center tap rectifier, here it will be D1 and here it will be D2. Okay, so what is the advantage of the center tap rectifier? I just explain you with the ideal diode, right? For the practical diode, if this is V, then what will be this potential? V minus 0.7, right? But for the bridge rectifier, what will happen? For the bridge rectifier, then this will be V minus 1.4. Why? As here you can see D1 and D2, both the diodes are conducting together, right? So the voltage drop will be 1.4 volt. But for the center tap diode, the voltage drop will be only 0.7 volt for 1/2 cycle. Okay, this is the first difference. Second difference is the current capacity for the bridge rectifier is much higher than the cylinder rectifier. Why? For the bridge rectifier, you can see two diodes is conducting together. Okay. For the cylinder rectifier, one diode is conducting only. Okay. The second one. And third one is for the center tap rectifier, we need a center tap transformer. Okay. So without a transformer, without a center tap transformer, we cannot make a center tap rectifier. But for the bridge rectifier, I need a AC source with positive and negative, right? That means if we have a 230 volt AC and somehow if I just step down to 24 volt AC, then also we can do that one, right? Like I think you already used some torchlight in like around 5 to 6 or 10 years ago, okay? At that one, you directly plug into the electricity board, right? For the charge, right? And you can see that torchlight is very small, right? So that means in that particular torchlight, there is no transformer. So how that one charge the battery? At that one, we have a circuit like resistance and a capacitor like this. And then we have a bridge rectifier. Okay, and here we have the AC source. This particular resistance and capacitor decrease the 230 volt to 24 volt, and then we use a bridge rectifier to convert to the DC. But for the center tap, you cannot do that one. Why? You need a actual center tap transformer for this thing. Okay, so the size of the device will be bulky and the weight of the device will be heavy. Okay, so that's why general case we never use a center tap transformer rectifier. Okay, general case we use the bridge rectifier. Okay, and for the RPS practical also we will use a bridge rectifier. Okay, and in that RPS practical video I will not explain everything like this. I will just skip the rectifier part. Okay, that's why I make this kind of video: bridge rectifier, center rectifier. Then I will make a capacitive filter. I already have some video on the capacitive filter. I will make a capacitive filter video, then the regulator. Okay, so that will be easier and that will create a fundamental base for the regulated power supply video, as that is not a easy practical. Okay, so that's all about the concept of the rectifier, concept of full wave rectifier, concept of half wave rectifier. About the calculation, I already told you, you will get all of this calculation in any book, or I will also give you my handwritten note in the description box, as well as you can find in the pin comment. Maybe not today, maybe tomorrow. Okay. For the center tap rectifier, first I need to explain you about the center tap transformer. Here you can see this is the center tap transformer. This is a 1:1 ratio. Okay, turn ratio. So you can see here the input voltage I give is the 10 volt, right? So this voltmeter, the blue one, is read plus minus 10 volt, right? So here you can see plus 10 volt minus 10 volt range, right? And I connect two voltmeter to the above half and the below half. Okay, here you can see the green one is reading plus minus 5 volt, right? And the orange one is reading plus minus 5 volt. That means if I combine this green one and orange one, it will be exactly same with the blue one. Okay, so if I do in the same, you can see if I click on the green one, you can see this will be green, and if I click on the orange one, it will be exactly orange. So the green one and orange one is identical waveform, so it is overlapping. And if I just add these two, then we will get the blue one. Okay. So this is the concept of the center tap transformer. Now I will explain you the circuit operation of the center tap rectifier. So here I make the center tap rectifier circuit, okay? And you can see that what I did, I just reversely connect this voltmeter such that you will understand that when this diode is forward bias, you can see this waveform, okay? So let's simulate this circuit and we need to check the input waveform. So the input waveform I can check from here. So this is the input waveform, right? And if I need to check the input before the diode, then you can see this is a half, right? Just as per the center tap transformer principle of operation. Okay. And if I click this one, you can see why this is the opposite as I just reverse the voltmeter. Okay. For the positive half cycle, the green one waveform, this diode will be in the forward bias, right? And for the negative half cycle, you can see that this diode will be in the forward bias, okay? And the output will be like this. See that? You understood? Right? So, I will explain the operation of the circuit with the first, this is the input, this is the output. So, you can see that this is just act as a half-wave rectifier, okay? So, you can see the current flow mechanism. If I just increase the voltage, yeah, you can see that this diode is operating. This diode is operating when for the positive half cycle, okay? And now I will explain you for the negative half cycle. Here you can see for the negative half cycle, this diode is operating and in the forward bias, okay? So center tap transformer is little bit different than the normal transformer. If you have any difficulty, maybe you can see this video again, and after that, if you didn't understand, just call me. I will explain you. Okay? So this is all about the simulation. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.